Hey, welcome to this video of ViZDoom. So what we are doing in this series is we are using the computer to play Doom for us, which is an ancient FPS from the 90s. It sort of predates Quake and CS and so on. We are getting the computer to learn to play by itself. We're creating a neural net, but it's initialized randomly, and that net is going to have to learn to see the world, to perceive the world, to figure out what to do. It gets given inputs, which is like what it sees, and the output is it press some buttons. I mean, virtual buttons, and it learned. So we use something called policy gradients, otherwise known as reinforce. And the model learnt, and in video 9-ish, 8 maybe, you can see what the computer, how the computer plays, and it's basically just like moving to point to the monster and then firing, moving point to the monster and then firing. In this video, so when we trained that model, we were so the reinforcement algorithm creates a loss. Through the reinforce, you get a loss that you backprop, and we were so the backprop is every episode, but we were then updating the parameters of the network also every episode. So there was a lot of variance in the parameter updates we can imagine, since sometimes it wins and sometimes it loses. So what we introduced was gradient accumulation, where we backprop gradients each episode, but we only apply the gradients to the weights every 16 episodes. So this averages out the gradients and hopefully stabilizes the learning. That's the plan. So in this video, we're going to look at the results from that. Oh, and also in the last video, we tried a second experiment where we are still accumulating gradients, but we increased the learning rate 4 times. Why 4? Well, because we increased the batch size 16 times from 1 to 16. And a rule that I've heard somewhere along the lines is that when you increase the batch size, you need to increase the learning rate by the square root of that increase. So here we increased the batch size by 16, so we increased the learning rate by the square root of 16, which is 4. Onward to the rest of the video. All right, so let's take a look at how the 2 training runs are going. So we've got 2 runs going. We've got this one finished, and then so these runs are all the 3 runs that were using the original per episode learning. And then we have 2 runs which are using the gradient accumulation. So we've got this one. This is running on instance 1, and we've got another one which has a higher learning rate. So I have no idea what the results are. I haven't checked. I'm trying to film myself while I check. So I don't know what either of them like. They would both be terrible or both be good. I have no idea. All right. So these are the 2 runs that we have that are batched. And what day is it today? It's Monday. So I don't know when I started that one, but like, I guess I could check my log. That's Sunday and Monday. Let me check my log. I've got a log somewhere. Here we go. ViZDoom log. Probably not good to open 2 of them, especially since this has been really slow for some reason. All right, so today is the 11th, so Monday is the 11th. So the Sunday was the 10th. Okay, so the higher learning rate started on Sunday morning at around 8 o'clock. Then the batched one, like without the higher learning rate, that started sort of in the middle of that 3rd run. Okay, so I think this is how it's looking. But obviously, like, I mean, this is still running now, right? Yeah, so basically I'm going to check on these 2. So both been running for like a couple of days. I have no idea what they look like. I haven't looked. All right, so we've got these log files. This one, run 4. All right, so this one is the first gradient accumulation where we did not increase the learning rate. So we just used the same learning rate as for per episode, but using the gradient accumulation over 16 episodes. So see how this looks. What? Oh, I need to have a Python script. So what is it? Is it graph batched? Log batched. Oh, right, there we go. In log file. Yeah. Oh, and then I have to open. I should probably do this a different way. Graph.png. Cool. All right. So I mean that's super stable. This is 140,000 batches, and each batch is 16 episodes, right? Oh wait, it's opening a different. I have to grey that out, I guess. All right. Let's hope it opens in this desktop. There we go. All right. So that's clearly learning, and it's very stable. Like 140,000 batches is 2 million episodes, and it's rock solid stable. Right. No issue at all. All right. So using the gradient accumulation has basically stabilized the learning significantly. I mean, it just doesn't have any issues. So now the question is, how long did it take to learn? So we can't really see here. So let's do like max batch. And we'll sort of dig down a bit. So max batch, let's do, I don't know, max batch 40,000. All right, so there's a bug here. So subler ViZDoom graph log batch py and the line 15 row. So this should probably, what was the error? No, this should be max batch, right? All right, let's drill further. So let's go down to say 15,000. I mean, this would obviously be easy using like MLflow or TensorBoard, but whatever. All right, so basically it's learned by, I mean, it's learned somewhere between 6,000 and 10,000. Let's call it 10,000, right? So 10,000 batches is, 160,000 episodes. So it's learning more slowly than when we were just doing the learning per episode. Because per episode, it had learned after about 40,000 episodes, right? Whereas here it's learning after 160,000 episodes. So it's learning 4 times more slowly. But that fits in with our idea that we have to increase the learning rate 4 times. So what about the other one, right? So we have this other graph too, which is run 5, where we increase the learning rate 4 times. So how's that looking? Interesting. All right, so there's a few more instabilities with the higher learning rate, but basically it looks like it's learned. So this has been running for 80,000 batches times 16 episodes. So this is run for 1.2 million. So it's pretty stable. I mean, there's a few excursions, but seems okay. We should probably look at those excursions. So let's drill down to 10,000 batches. All right, so basically it's learned by about 2,000 batches, right? Should we drill down to 4,000? Yeah, it's learned by about batch 2,000, I would say. So how many episodes is that? 32,000. All right, so if we make the learning rate 4 times higher, it learns about as quickly as when we did it per episode, but it's much more stable. Like basically if I take away the max batch, It's gone up to 80,000 batches, which, as we said, is 1.2 million episodes. Whereas before it fell over after like 100,000 when we were doing per episode. I kind of want to see these excursions. So this is around 34,000 to. Oh, I don't have a min batch, right? I mean, we could try max batch 4,000. Yeah, the learning kind of did collapse here, but then came back on track. You can see it went down and then it went up again. So that's not ideal, but at least it recovered, whereas like the first time it didn't recover. But yeah, it might be good to fix those, but I don't think I'm going to put any effort into fixing that right now. Yeah, so good. Okay, so result number 1, accumulating the gradients increase the stability. If we result number 2, when we accumulate the gradients, we need to multiply the learning rate by the square root of the number of episodes in the effective batch. So here the effective batch is 16, square root of 16 is 4, so we need to multiply the learning rate by 4. There's still the occasional instability when we do that, like if we have the accumulated batches plus the 4 times higher learning rate, but it does recover. It might be nice to fix that, but I'm not going to fix that right now. As far as like the learning speed is actually the same if we update the weights every episode, or if we update the weights every 16 episodes. Well, no, that's not true. If we compare updating per episode with a learning rate 4 times higher, then the model learns the task in about the same time. It's both about 40,000 episodes. If we only add the gradient accumulation without increasing the learning rate, then it's 4 times slower. It took 160,000 episodes in that case. But on the whole, I would say that the gradient accumulation is a win. Gradient accumulation with a 4 times higher learning rate seems like a win. I guess that's the end of this video. So if you liked it, well, no. If you've got any comments on what you think of the video, what I could improve, what I could do differently, what I did wrongly, ideas for future videos, things that you'd like to see, things you'd like to see me try, please put that in the comments. If you liked the video, please click like, and hopefully see you in the next video.